So I've seen that some of the estimates for smart contracts and what they could save to the supply chain industry generally every year is around 500 billion to 1 trillion. I think one of the most well-known projects was the Walmart project, where they had lots of disputes around delivery and provenance of good. And the average time it took was 7 days to prove provenance of a product. And just by using distributed ledger technology and smart contracts in this, it went down to 2.2 seconds, which is quite an immediate impact for quite a big company. Welcome to another episode of the Untangling Web3 podcast. I'm joined today by Jack Davis, as I'm always joined. How are you doing today, Jack?
I never had such a special intro before. Thanks, Alec. Yeah.
So you're getting nervous.
Yeah, I thought maybe there was a special guest coming in that I wasn't expecting, but no, it's just us today. Yeah, no, doing well. Pretty into the swing of things of the new year now. At the time of recording, everyone's talking about this ETF. As always, it potentially is going to be approved while we're recording this. So let's find out later. But yeah, pretty good. How are you?
Yeah, not too bad. It seems like all anyone is talking about right now is the ETF. I'm kind of just hoping that it's going to pass soon and we can move back to other things apart from ETF. But you are right. And speaking of other things that aren't the Bitcoin ETF, today we'll be talking about smart contracts. Jack, how do you feel about smart contracts?
I feel like it's a term that is used way too much and bandied around. And I think there's a debate over how smart they really are. But it's no getting away from the fact that it is a fundamental component of Web3, right? A lot of DeFi, a lot of apps in Web3 run off them. So it's worth us taking the time to break them down, explain exactly what they are, I think.
Yeah, you're right. I mean, it's a shock that you're being a negative Nancy about this, but I actually completely agree with you. Like, contracts are boring, right? A contract's an agreement between two parties where they promise to do something. And when we're talking about smart contracts, it's just how can we automate that in a way? And I think a lot of people miss that. They think it's more intelligent than it actually is. And it's effectively just automated execution of code, and the code equals a contract. But maybe we're getting a bit ahead of ourselves. And should we go to the start of all things contracts?
Yeah, why not? We just said they're boring. So why don't we spend the first few minutes of the episode talking about them in great detail?
Yeah, exactly. So let's go back to where everything always starts. It's always ancient times, Mesopotamia, 3000 BC. Really exciting stuff. I think that one of the earliest texts that we ever recorded was a Code of Hammurabi. And this was effectively one of the first contracts. It was rules for commercial interactions and provisions for contracts and their regulation. Classic capitalism, started nice and early. And one of the interesting facts around this was that they were actually written on clay tablets. And the beautiful thing about this was they were sealed. And this was meant to provide a tamper-proof record of the contract. So you write the contract, and if someone disputes it 1,000 years down the line or something like that, you crack open the seal and say, well, these are the terms. Don't know how usable that is, but it's quite interesting to see that they're using the term tamper-proof back in those days.
That's interesting. We've always had the same problems, right? There's different ways of solving them. We've got slightly more advanced solutions to the tamper-proof problem now with blockchain. But yeah, so the contracts have been around. We talked about the barter system and whether or not it really exists, but this idea of you needing to mediate exchange, right? And not just exchanging items for items, but having ways of encoding and writing down different types of value exchange, right? And that's where contracts come in. They're ways of defining the obligations on both parties, and they've been around for so long. And ancient Rome as well developed, brought them even further forward, codifying them, bringing in this idea of having sets of rules and sets of contracts that can apply in various different areas. So it goes back a very long way, and it's something I think we're all still familiar with, right? Even through its development through things like the modern age in the 17th, 18th century, you have the Industrial Revolution, for example. You have that demand coming in for, you have new industries happening. You need to codify more complex interactions. You need to standardize legally binding contracts, because one of the issues with contracts is if one party doesn't hold up their obligations, what do you do? And effectively, throughout the centuries, we've had this evolution of the legal system alongside the evolution of contracts to allow you to have basically a means of recourse when things go wrong.
Yeah, you know that classic meme, how many times a day does someone think about Rome? Jack's is every hour of every day, always. But yeah, I think one of the most interesting things about the evolution of contracts when you were talking about the 17th and 18th century was a shift towards more standardized and like legally binding contracts that anyone could use. And this was really to do with like complexity of industrialization and a globalized, interconnected economy. They had things like corporations. There was no longer people making contracts with people. It was entities, like legal entities, making contracts with other entities, and they could, enter contracts, own properties, be liable for things, and they weren't really people. They were just entities that people invested into, and that was it's quite interesting. And I think that's particularly related to how we view DAOs now, and like the stepping stone of people making contracts with people, and then entities making contracts with entities. Kind of similar to maybe one of the steps of DAOs making contracts with DAOs and all the participants in DAOs, and how we think, okay, how does this work? Who's accountable? But really, there are mechanisms that exist today that should apply to DAOs, and DAOs aren't really anything special. Yeah, I think so. We've come to the modern age, effectively. Everything's been paper-based up until this. Contracts are physical, obviously, on paper, up until the end of the 20th century, effectively. I think it's good to take a step back at this stage before we move into the digital age to really define what is a contract in quite simple terms.
Yeah, exactly. It's something that makes sense intuitively to us, right? What is a contract? It's something you maybe will sign when you are employed, an employment contract. You might have a contract for a loan or something. We've all seen them, but they all share kind of common features, right? So typically a kind of raw contract, so the raw form, what is actually the content of it? You have the terms of the contract. So that essentially is the details of what each party is obliged to do, and that's clearly stated. So what are the obligations on each party involved in a value exchange, essentially? That's the core second part. What is the exchange of value? What is being exchanged? Is it goods, services, money? What is each party promising the other? And that can obviously vary in different cases, but that's the through line through basically virtually all contracts. To oversimplify, at the risk of angering any kind of contract law professionals, in the audience, that is a simple thing, right? You have the terms of the contract, and then you have what is being exchanged, and both parties then are beholden to those rules and that exchange of value.
Yeah, I mean, this is a massive oversimplification. When we're looking into this, there was like 10 different items, and I was like, God damn, this is way too complicated. Let's really take it back to make it relevant and understandable for smart contracts. So yeah, you're right. The contract itself, as most people can think of it, the document, it has terms in it and some kind of exchange of value based on those terms. And then the next bit, if we categorize and kind of group things together, is the signing and consent. You have this physical document on paper that says someone needs to do something if something happens, and then I have to consent to it. It could be both parties, multiple parties, and this is effectively me applying my identity in some way and consent to the terms that are in the document. And there's some boring things around, the person that signs it must be free and sound of mind to do so. But they're the three really high level things that we want to define in a contract and the signatures of a contract. It's the terms, the exchange, and the signatures or the consent that actually to those terms and the exchange of value. And then now we can come to the digital age, right? So obviously contracts move from paper-based to the digital age for obvious reasons, convenience, efficiencies, and all these kind of things. And at first, digital contracts were exact replicas of the physical contracts. The terms were written out in, Word, for example. Signatures were still just little squigglies, like little images that you could make on your pad, and it would just be JPEG that you put onto the digital file. But then they got so much smarter, and this is where it gets really interesting.
Yeah, exactly. It takes time for technology to properly affect different industries, right? And yeah, most of us who've interacted with a contract digitally will have been probably via a PDF, right? And you're signing it, doing a little squiggly with your mouse that's impossible to do. But, it's kind of just mimicking what we have in the physical world with paper-based contracts. And now what we've seen over the kind of last 20 years or so, maybe slightly longer, is actually integrating the more robust technologies into securing these contracts, better ways for signing them, right? So we talk about digital signatures a lot. That's a core component of what digital contracts are in the modern age. Okay, so we use digital signatures, we use these cryptographic foundations that we've had working for kind of 40, 50 years now. We trust them, and they're being used ever more in our daily lives to secure these contracts.
So let's give an example here. So Jack's talking about digital signatures, and we haven't really defined them properly, but we can talk about them at a high level. If we think about the issues we have with, say, physical contracts and digital contracts in the way I just explained it. So imagine, I send Jack a contract, say I'm paying him $1 million for his autograph, as Jack would really like to do in the future. He signs it and then sends it back to me. So now I know what his signature looks like, this little visual squiggly, effectively. I could just use that signature for any contract. I could even change our original contract to say that Jack owes me $1 million. Like, for anyone that's had to have their parents sign homework for parents' evening, all this kind of stuff, it's so easy to just forge your mom's signature and just change it to anything. And this is one of the big issues that we had before digital signature technology was actually used for digital contracts.
Yeah, that's why I'll never sign a contract with you, Alec. I'm afraid I don't trust you. But yeah, one thing I found interesting is my first ever memory of signing something was, I think it was my library card when I was kind of 8 or 9 years old,
Of course
right?
it was.
Yeah, yeah. What else would it be? And the interesting thing was, I remember writing my signature for the first time, terrible as it was, and thinking, how is this? How is this safe? Can't this be reused? Right? And this problem you're talking about is what we call like replayability. Basically, that's the kind of the. I wasn't thinking about it in those terms when I was 8 or 9, but now much older, you can see what these things actually are. Right? This is a known problem because you can take that signature, you can once you've seen it, you can reproduce it very easily on a different document. You can transfer that signature to another document, and the binding from between the actual signature that's on a given document is quite loose, right? It doesn't bind to your identity very well. That's where the digital signatures improve on this so much. Not only are they bound to documents, but we say they depend on the document, right? So one signature will apply to one document. That same signature can't just be lifted and put on another document. That's part of the cryptography guarantees that are baked in. But you can then also link the keys used to sign these documents to a real world identity, which is, again, part of the power of this. You can prove very easily that a signature belongs or is associated with a given person in the digital world.
I'm just still stuck on the idea of you being like 10 years old in a library, having an existential crisis, being like, they could use this signature for anything. What about my bank accounts and my investments and all this kind of stuff? Your character arc is so obvious. You were so obviously going to go into the world of Web3, having a breakdown at 10 years old in the library. But yeah, so we don't want to go too deep into digital signatures. We're going to have an entire episode, but I think it would probably detract too much from the idea and concept of smart contracts generally. So what Jack just described is effectively digital signatures are mathematical computations in a way, and they kind of go beyond the visual squigglies that we were used to before that and added all the benefits that Jack said. So to keep it simple, digital signatures applied to, say, contracts like we just talked about them, they will prevent changes. So if anyone tries to change the contract after it's been signed with a digital signature, the signature won't work anymore. So this shows that the contract was altered or that it's actually not been altered. That's quite a powerful thing. And then the second main benefit we get from this is it stops signature theft. So each digital signature is unique and can't be copied to another document. So it's like a lock that only fits one key, and that keeps the signature safe from being used or stolen, as Jack just mentioned. And that's really powerful. It really starts to apply like strong identity characteristics and strong provability to say, if I've got a key that's linked to Jack's identity and a signature that only he can generate for this document, then he has to have signed it, assuming that the key didn't get misplaced or something like that. So that is digital contracts, right? We're kind of up to scratch, and that's where we're at in the modern age, effectively.
Yeah, and just one other point I'd mention there, right, is that why these signatures are so powerful, digital signatures now, is that they also have more legal weight than they did previously as well, right? So more recently, they have been given equal legal status to physical signatures. I mean, arguably, physical signatures maybe should go down a peg. In the UK, a digital signature or electronic signature has the same weight as a written one as the e-sign Act in America. So yeah, it's just worth mentioning that from a legal perspective, when we talk about contracts giving you legal means of recourse when something goes wrong, the digital signatures now, they help enforce that. So yeah, we're now in this world of modern digital contracts. We've gone from clay to paper to digital to, let's say, modern or cryptographic digital contracts, which is much more powerful. And then you hit the early 90s and we start getting this new term come about, which is smart contracts, right? So where did that come from?
My understanding is there was this very intelligent fella called Nick Szabo from who originated the concept of smart contracts in 1994. So he was a computer scientist, a cryptographer, and he was effectively doing research into digital contracts and digital currencies. And I think he first coined the term smart contract, which is so misused, as me and Jack said earlier in the show, in 1994. And effectively, his vision was quite simple. It was around the idea of automated systems that could execute the terms of any contract. So you're effectively codifying smart contract terminology into hardware and software that could be executed. And I really like the analogy that they use. They compare like a smart contract to a vending machine. Just as a vending machine automatically enforces the sale, I put my money in, I know what I expect, it's transparent. And then the kind of the smart contract as the vending machine is executed when I put my money in to dispense the crisps or the chocolate, whatever I'm eating. That's effectively what he wanted to do, was to use smart contracts to automatically enforce the terms that are encoded into some software piece.
Yeah, and when Nick Szabo started talking about smart contracts, it was very visionary thinking, right? And it kind of had a few different components. So it had the cryptographic elements that we talked about, having digital signatures. It had this idea of automation at the heart of it, as you said, so being able to automatically execute contracts instead of having to kind of do manual physical processes. And also that he introduced this idea of using a distributed network to enforce them as well, and how they get executed, which is really interesting. And lots of this, I don't want to say inspired Bitcoin, but you can definitely see similarities between what was in these thinkings from Szabo in the early 90s and what we eventually end up with Bitcoin. And I'll just say one reason you don't love the word smart contracts is because in the 1990s, the term was used to describe the objects in the Stanford Digital Library project, right? They look very different to what we mean in the modern world with Web3 smart contracts. But, it's interesting that that term has been around for a very long time, right?
As I say, so just to bring it back to what we were talking about earlier, when we said a contract has three important pieces at a high level: the terms, the signature, and the exchange of value. We've talked about how digital signature technology has kind of reinforced the terms and made them difficult to change or tamper-proof in a way. We've talked about how that is done by enforcing digital signature technology. And this whole idea of smart contracts is effectively improving the exchange of value concept. So it's talking about how the exchange of value can be automated based on some terms. And also what Jack mentioned there is Szabo was thinking about how these contracts could be hosted in a distributed ledger. And that also makes the terms more transparent, more visible. Two parties are transacting or over a contract. It's very easy to prove that both parties had the same terms if it's hosted in a distributed ledger, for example.
Yeah, and Szabo was looking at this from the perspective of money, really, right? He was very interested in digital cash systems. So the contracts he was looking at were really payment contracts, terms and conditions for paying people in a distributed way. And he came up with the ideas for BitGold as well in the similar time. So he was thinking about this from a digital cash, digital money type scenario, and that's what led things forward. There's another type of contract. I'm not going to go into the detail called Ricardian contracts. I'm just going to name drop it in there because there's a kind of alternative, but similar thinking that was happening in parallel. So maybe we'll pick up on that in another episode.
Yeah,
but
hashtag Ricardian contracts. It's going to get a big upvote.
Yeah, if you want to see an episode on Ricardian contracts, just send us an email. But yeah, so following on from Nick Szabo's early writings and some of the projects that were worked on, then you don't have too much happening until the advent of Bitcoin, right? And I said, there are similarities. In Bitcoin, that's the first time we really saw all these ideas of cryptography, automation, distributed execution across a network for payments and for these kind of smart programs. Okay, we call it like programmatic money sometimes. So you see a number of years wait, and then Bitcoin comes out in 2008 and 2009. That popularizes blockchain, and blockchain fast becomes, people see it very much then as the platform upon which we can have smart contracts. It's the way and the infrastructure for implementing these ideas that were first thought about kind of 15, 20 years ago. Then you come to 2015 with Ethereum, and that really takes off as the de facto smart contract platform, right? So all the way from 1990s to the present day, Ethereum was the point really that marked the widespread use and it becoming a household name effectively of smart contracts. It became a smart contract platform where you could deploy them on the blockchain. They kind of live as their own entities, right? It's funny that you say contracts over time have developed from representing individuals to corporations as entities. Now smart contracts have taken on a life of their own, right? And we'll kind of get into the details of how they work in a minute. But really, you can think of them as like first-class citizens in the Web3 world.
Okay, so just to take it back to what a smart contract is, like me and Jack were saying, it's effectively a self-executing contract, right? With the terms of the agreement between the parties written in code, okay? And it is hosted in a distributed, or ideally hosted in a distributed blockchain network, as Jack just mentioned. So let's just give an example just to explain how this would work. So the first stage would be to set up a contract. So I can program a smart contract that says this car can be used for 3 days for £100, okay? And then there's some payment element. If Jack sees the smart contract, he pays to the smart contract £100 in digital currency, for example, which the smart contract holds in escrow on behalf of the two parties, which is another benefit of this. Then the contract says, okay, well, the condition's been met. So he's transferred £100 to me. That's the terms. Once the payment's confirmed, the smart contract will then automatically unlock the car for Jack's use. And then the smart contract will end the contract after 3 days, and the car will be automatically locked, ending the rental agreement. Fairly simple example, but I think it kind of highlights why we would want to use this.
Yeah, and the key point there is that all these different rules, well, again, there are some more complex examples that are harder, but most rules that you can think of in a contract can be translated into one of these machine executable versions, right? Something that works in a smart contract that can be executed and verified by a node in a blockchain network, right? So yeah, it's interesting how much of this can be ported over. It's not to say that all you need is a smart contract, and we'll kind of get onto the legal regulatory side of this later. But you get some distinct benefits of this way of doing things, right? First and foremost, you do get this automated execution that we talk about. So your smart contract is effectively living on, let's say, the Ethereum network, right? It lives on the Ethereum blockchain. It just sits up there until you want to do something with that contract, whatever it might be. This could be your insurance contract. And then one day you say, I want to make a claim on that insurance. And then I'm going to interact with the contracts. All that gets done in an automated way in the Ethereum network. I interact with it, and then that gets done in a distributed way. And it's not just one entity you're relying on as a central point of failure. You have this whole network of potential validators for your action. So you have that kind of redundancy, that improvement.
Yeah. It's also the security, the fact that there's multiple nodes hosting it. So it's unlikely that the smart contract's ever going to go down, which obviously if we have a paper-based document, it's on one of us to store and hold that forever. Like another benefit is obviously, well, this is a theorized benefit. It's meant to be the lower costs, but obviously we know smart contracts right now and a lot of implementations probably aren't more cost effective than it would be to go to a lawyer and start paying things. That's another potential benefit of automation. Always, we have the accuracy and transparency. That's particularly important when you're interacting with more than one party, effectively, to say, okay, this is a defined way to provably say we both have the exact same terms because there's only one version of the smart contract and that's hosted in this distributed network. That's another big benefit because you have loads of legal disputes around, okay, the terms that I signed off on weren't the terms that we agreed originally. And this is a very nice way of proving that, okay, the terms had to be the same at this point. And obviously we have all the benefits around efficiency as well. So lots and lots of theorized benefits around smart contracts.
Yeah, that's an interesting one, the accuracy one, right? Because that's probably more specific to digital contracts in general, and we just also get it in the Web3 smart contracting world. One benefit that is, I would say, probably exclusive to Web3 and blockchain-based or blockchain-hosted smart contracts is, as you said earlier, they are intrinsically linked to money in a sense, right? Because you already have these tokens and a tokenized world on Ethereum or on whatever smart contract blockchain you're using. So you can just link the payment directly to the execution. It's not like in the existing world where you have the contract as one document and that might define a payment, and then you have to go on a payment provider to do the payment. You can actually put them into one, which is, again, where some of those theorized efficiency gains come from, I think.
Yeah. So I think when we're kind of moving towards the idea of smart contracts versus normal digital contracts, there's kind of three new elements that I think we have to discuss. One is the blockchain technology. So, the platform, the execution, how things are hosted reliably. The other one is the programming language, and that's quite dependent on the blockchain technology that you're actually using. So how the terms are actually written and codified, how the contract is actually converted into programming language effectively. And then there's things around execution and triggers. What actually causes this contract to execute? We talked about terms, but how does that data get in to define the terms? Like a blockchain in itself isn't always useful. Not everything's around payment to payment, right? You also want data saying, okay, in that instance, I want to unlock a car, or some time has elapsed since that car was unlocked based on the funds. And then we start to get into the realm of like oracles, transfers, funds, all this kind of stuff. So like Jack mentioned, 2008, that was probably the popularized example of distributed ledger or blockchain technology, sorry. And this was ideal for executing and recording the smart contracts in a secure and transparent way. And one of the beautiful things was they had native tokens, as Jack just highlighted, to actually exchange value within the smart contracts. And I think there's a bit of a misunderstanding here around Bitcoin, right? I think most people think, okay, well, you actually can't do smart contracts in Bitcoin. There's no programmability, but that's not necessarily true, is it, Jack?
No, this is a really interesting topic. I was going to ask, what is your opinion, right? Because in my world, Bitcoin very much does have smart contracts in the way we've defined them. Okay, you can create conditional payments. You can set up all these kind of complex multi-party payments and conditional things. There's so much you can do with the expressiveness of Bitcoin script, and script is that programming language that comes
Mm.
in Bitcoin natively. There's lots you can do with it just as is. Okay. The problem that people had with considering this like smart contracts is that it's not as expressive as it could be. So the language in and of itself isn't what we call Turing complete. Okay, I'm not going to geek out too much. It just means you can't do all the most complex things without in a very easy way. Okay, there are ways to get around this, and one of the reasons I think people don't consider Bitcoin as a smart contract platform is that there were changes made a little while ago, a number of years ago, to kind of limit some of the functionalities you could do in script that actually made it even less expressive than it was when it was published. The code was published in 2009, so it was kind of limited in that way. But we've seen other chains actually re-enable a lot of these capabilities, and you can do extremely expressive things with just Bitcoin as it is. So it's interesting. In my opinion, they do. Well, what do you think?
I think like the way that I described it before is that Bitcoin's smart contract language or programming language is similar to like assembly code. Really, it's like fairly basic. You can do almost anything on it, but it takes a lot of effort. But the beauty is it's very robust and very well understood. And once you've got something dialed, it works very effectively and you know exactly how it will work, right? But not many people want to program in assembly code. Whereas Ethereum and Solidity is much more like Python. Easy to pick up, easy to do, very fast to deployment, right? But the problem is you don't know exactly how things are going to work in the background. And this is why you have all the potential hacks, because there's so many people building on Solidity that don't exactly know how the functions are being deployed properly. And it's a bit more complicated because it's so easy to pick up. So that's how I would describe the two. And I think, yeah, the misunderstanding is probably around how easy it is to take and implement with. And there's not many projects, right, building smart contracts on Bitcoin right now. And that's probably the major consideration.
Yeah, definitely. And I'm really glad you mentioned Solidity, right? Because that is one of the big differentiators why Ethereum is considered a smart contract platform, is that you had Solidity, which is what we call a high level programming language that actually allows you to write things as if it was, a bit more like JavaScript, the most popular language in the world, I think, unless it's Python now, but it's in the top two at least. So you can write things in a very normal way, in a way that you're used to, and write these conditions for your smart contracts, and it's very easy to do. And Bitcoin really never had one of these high-level languages developed for it, because Solidity was not baked into Ethereum. It was built on top as a developer tool, essentially, but it did it fast and it got a lot of adoption, whereas Bitcoin never had that. Actually, at the base layer, Ethereum is also very similar to Bitcoin in the scripting sense, right? It is similarly like an assembly type language. The difference is it has this really impressive thing called the EVM, the Ethereum virtual machine. And that's one thing that Bitcoin doesn't have in the same way. So the EVM is essentially, that's like the computer on a given node. That's the computer that runs the program. So once you've written a program in Solidity, the EVM is the thing that's going to say, does this program work, right? Given some inputs, will it give you the right outputs? And in Ethereum, the EVM allows you to do more effectively and more easily than you can do in Bitcoin. So there's kind of two different sides to the coin, but it's very much an Ethereum dominated landscape in smart contracts today, right?
Yeah, and I think we've talked about, some of the deployments in a previous episode and some of the issues that DAO hack in 2016, which is effectively people not necessarily understanding how they were programming smart contracts on Ethereum. And that led to someone being able to siphon off $50 million on the side without anyone being able to do anything. And that caused the fork that we spoke about previously. And I think, there's a whole host of developer tools, developer support on Ethereum right now. I mean, just to name a few, Infura, Truffle. And I think one of the interesting things is, isn't Infura down like 50% of all network transactions on Ethereum or something like this come through Infura? And there's this whole argument around, okay, if Ethereum really is decentralized, if one operator goes down, one service provider, which is Infura, 50% of the network disappears. Like, is that really decentralized?
Yeah, I feel like the number is actually much higher. I don't know it off
Really?
the top of my head, but my gut feeling is it's very high, right? That's what everyone tends to use to write their smart contracts. And another thing that Ethereum has is they've done a very good job of standardizing smart contracts, right? And different templates like boilerplate code. So if you want to go and make a fungible token, you have ERC20. That's a standard. You can just go and copy and paste the code, change some things, and boom, you've got a token in 10 minutes if you want it. It's unbelievable. And all the other services then Infura like that can help you deploy it. But actually, what the smart contracts are themselves is very intuitive. You can go and do a non-fungible token very easy, ERC 721. You've even got things like soul-bound tokens recently, or things like non-transferable tokens that can be used to represent digital identity. And you can go from that kind of the simpler token systems to much, much more expressive things like automated market makers, as we talked about in the DeFi episode. All of Uniswap is being run from a smart contract or a collection of smart contracts, right? Everything that happens is based on smart contract code, which is mind-boggling, right? Given how much it's used, the money deposited, the daily volume of Uniswap. It's unbelievable.
I think like that point is really important around the token standardization. Like when you have 1,000 different companies all building 1,000 different types of token, Jack has his crypto kitty or whatever it is, I have my digital identity. Like you want interoperability. We don't want the two tokens that we have from two separate companies and then no ability to exchange and do similar overlapping services between them. So these standards are really important so that users can move between companies, tokens can move between companies. You can start to amalgamate different tokens together. And it's something that Ethereum has done very well with these emerging standards, and it makes it so much more usable and intuitive for the users as well.
Yeah, exactly. And we've talked about a lot of the pros there, right, of why these things are good, why smart contracts are good. There are some downsides. It's probably worth mentioning as well. So because they're so expressive, because they can be used to do such incredible things, now there's an ethos of kind of, you'll hear the term code is law, right? So that just using smart contracts on their own to define legal agreements, and really that doesn't really seem to square with the real world in practice. We've heard that time and time again from people on the show, from elsewhere. Smart contracts on their own are good at the automation step. They're good at helping you enforce or operate a contract, but they're not necessarily fit for purpose in and of their own for all types of contract. A lot of the time you still will want some legal system, or you'll have to draft the contract in the old world as a digital legal contract and then convert it into a smart contract.
Yeah, I think there's a really nice quote from Nick Szabo that I've actually got written down here. And it goes along the similar lines where he says, there's a strong distinction to be made between dry code smart contracts and wet code's physical law. So law is based on our minds, our wetware. It's based on analogy. The law is more flexible. Software is more rigid. Various laws tend to be batched in jurisdictional silos and software tends to be independent. And there's kind of like, he talks about the pros and cons there, right? One is law is flexible for a reason. It's like, if Jack has to pay me at the end of the month, or otherwise I repossess his house. Now, if Jack gets hit by a bus at the end of the month and he can't physically go to the bank, then there should be some flexibility in the law to say, okay, this isn't actually Jack's fault. And code isn't always like that, right? A lot of these smart contracts are binary. They're trying to take quite, I guess, varied degrees and spectrum-based law and turn it into something that's black and white. And it shouldn't always work like that. On the other hand, he's also saying there's some pros to this, right? Some things are black and white. And if you don't pay on this day, then it should be independent of any bias. And there's so much bias in law that actually is really bad, right? You've seen some of the studies and some of the stats about when judges are actually penalizing or judging over people in the morning or just before lunch, they actually have like 5% longer sentence on average. Bias is typically very bad, but there should be some flexibility in the law depending on circumstances. The smart contracts don't always capture that.
Yeah, exactly. And when you have the gray world that we live in, then trying to put that in a black and white setting on the blockchain is very difficult. And the more different eventualities in the real world you're trying to account for, the more complexity you add to the smart contracts, the more risk you add to something going wrong, not being able to fully predict the behavior of it, right? There's this principle in cybersecurity, keep it simple, stupid. Right. So the simpler it is, the less likely it is to go wrong because there's fewer variables to think about when testing the security of something. So yeah, it's one thing to be wary of in the smart contracting world. So not just the mentality towards them and being aware that they're not a replacement for the legal system. They're just a way of helping enforce the legal system effectively in a more efficient way. But they're not also necessarily fit for purpose in all cases as well, right? Because not always can they express all the conditions that you need for a given contract.
Yeah, that makes sense. I think one of the other issues that I see bounded about a lot is technical complexity. And I kind of have an issue with that, right? Is most people don't code. So the idea of like changing human readable language into code actually isn't going to help the readability of a smart contract. But have you tried to read like a legal terminology lately? It's complete jargon. I think it's probably, for me anyway, it's definitely less readable to have a lawyer draft up a contract than it is to program some basic conditioning in a smart contract or in some programming language. So I think this is just a change from legal jargon to, programming jargon. But I guess that is also a concern. And we've talked about the scalability, the cost right now. Smart contracts on Ethereum are not very efficient at all. They're extremely costly. Hopefully they're going to come down, but I guess that's one to TBD.
Yeah, and that's where you bring in the idea of layer one versus layer two again, right? As we've talked about, taking things to a second layer might increase the efficiency, but does it give you all the same benefits with the automated execution, the non-trusted environment that you want for these smart contracts? So that's a pretty good overview, I think, of how smart contracts actually work. Let's talk about the applications, right? So not just boring employment contracts and things, but let's go into where are they actually being used in the real world and what's actually exciting. So what do you think is one of the big application areas for smart contracts?
Yeah, let's go from boring contracts to even more boring supply chains. We've kind of talked about this on the show before. Obviously, supply chains are huge. This is a $1 trillion industry. Supply chains are needed for anything that's more complicated than a stick. And as like we're increasingly globalized, they're cross-border, they're cross-jurisdiction, cross everything, right? And I think we saw that global supply chains are actually not very resilient. COVID really emphasized that. The war in Ukraine's really emphasized that supply chains are very important, but they're also quite fragile. I think one of the most important things around supply chains is there's lots of different parties that are interacting, sometimes independent parties and lots of different actors that are completely independent. You imagine a farmer, then you imagine, the person that collects the farm produce. I don't know what that is. The person that transports it, the person that sells it.
Mm-hmm.
These people don't necessarily communicate very well together. And this creates a lot of paperwork and there's a lot of duplication, a lot of sense checking. It is incredibly slow. So I've seen that some of the estimates for smart contracts and what they could save to the supply chain industry generally every year is around 500 billion to 1 trillion. So it's huge, right? And that's like an immediate impact. I think one of the most well-known projects was the Walmart project, where they had lots of disputes around delivery and provenance of good. And the average time it took for, I forget, it was a certain type of product or a certain area, was 7 days to prove provenance of a product. And that's 7 days from someone trying to push the product to the next stage and the person there being like, okay, you need to prove that this is actually the product I want. And that took 7 days on average. And just by using distributed ledger technology and smart contracts in this, it went down to 2.2 seconds, which is quite an immediate impact for quite a big company. So how does this stuff work? Imagine you have a smart contract that's effectively collecting the data. Let's take the farmer, for example. He has some milk that he takes from the cow. As soon as it goes into the bottle, he tags an RFID or an IoT chip on that milk bottle to know this was created on my farm. I can produce a digital signature to prove that, and only I can do that for this good. Okay. So then we have a smart contract that actually monitors that milk and provides real-time tracking and verification of the goods using that farmer's digital signature at each decision point along the supply chain. And as it goes through the various actors, they can verify instantly that it came from the previous actor, and they can provide their own signature on that as well, be it automated with a smart contract and automated with IoT chips, where you just have an IoT chip going past a gate. But the point is, we've programmed every kind of transaction on the blockchain, which is effectively this being passed from point to point, actor to actor, and it allows us to really efficiently verify the authenticity of the milk, for example, from origin all the way through. And you can start to do, more intelligent things like prove transparency, prove that it was below a certain temperature, prove that it took a certain amount of time to get there. And I think smart contracts, when we think about IoT devices and IoT devices being used in supply chain, is extremely important. It's a lot of data that you don't want to handle manually. You want to automate the entire process. You don't want human error involved in the loop. And really excitingly, you want funds to be automatically released, right? If I have a smart contract between, say, the distributor and the farmer, as soon as that IoT device says that this milk has gone through that gate, the funds should be released via a smart contract from the distributor back to the farmer. And this is a really powerful thing, I think, for supply chains generally.
Yeah, I 100% agree. For a boring topic, is actually very interesting, I think.
What's yours, Jack? Can you take it even more boring than supply chains?
I'm sure I can. But I mean, just on that as well, I think it's worth adding that we spoke to David Palmer about the future of IoT in a previous episode, and he was talking about the economy that you can have with IoT and how they can interact with each other, interact with other systems, and basically giving them money to go and trade with or trade data with, right? Imagine an IoT device selling data in the marketplace. That's a kind of revolutionary idea. And you can have that all mediated through the smart contract. The other one of the reasons it's so beneficial to supply chain is this universal source of truth idea with blockchain, the fact that it's immutable, and the fact that blockchains are very good at having unique records, actually, not just unchangeable records, but everything is uniquely identified on a blockchain. It's a very special database in that sense, and that it's public, the kind of trifecta of benefits, so that everyone can be seeing off the same hymn sheet as this item, this bottle of milk is traversing through the supply chain, because everyone knows the smart contract, everyone knows the rules, which party does it go to next, what checks do they need to do, what data they need to submit. And then all the data itself is also going to be immutable and won't be able to change and can be checked. It can be error checked by the smart contract. If it's in the wrong format, for example, it could spit that back out and say, no, that doesn't work. You need to submit it again. The fact that everyone's singing off the same hymn sheet, the same smart contract, and it's uniquely identifiable is huge, I think.
Yeah, you're so Welsh, like constantly singing off hymn sheets. It's a bit of you, but you're not allowed to just piggyback on my application. You got to give me your own.
Hymn sheets in agriculture. That's what we have. I think another one, we've talked about it a lot recently, and this will be pretty obvious to everyone listening, but is the financial sector, all the use cases there. Okay.
Right,
what are the applications? Yeah, it's exciting for sure. It's a more boring old world thing, but the new version is very exciting. And really, we did a whole episode on DeFi. DeFi is smart contracts applied to the financial sector, right? So all these things we're seeing it happen in DeFi. Again, automated market makers, Uniswap, borrowing and lending protocols, using oracles to pay out things. Even gambling type use cases are interesting, I think. So, and not just because you can do new things, but also that this can be used to save money as well and make these things more efficient in theory. So again, PwC estimate that a business can save up to 2% of their annual costs by using contract management, right? Any business potentially, because of the inaccuracies it avoids, right? Maybe with payments. So 2% doesn't sound like a lot, but that will really impact the bottom line for lots of companies in the world, especially at the minute.
And we love talking about the bottom line. And I think, the boring stuff is the efficiency and the time saving, but that's what enterprises care about. The more exciting stuff is the idea of lowering barriers to entry and being able to have anyone contribute to some fund, or anyone being able to have a direct peer-to-peer funding service or something like this, just managed via a smart contract.
Yeah, and the financial sector is really where smart contracts actually, I think, combine most obviously with all the other aspects of Web3, like your oracles, because they'll feed in prices or other data like time. Because again, time is an interesting one, because the blockchain doesn't really know what time it is. Ethereum doesn't know what time it is. You can't feed that in. So you need oracles to do that if you're going to pay out on a certain date or pay back on a certain date for a loan, for example. So oracles are hugely important when used in conjunction with smart contracts. The same with decentralized exchanges, as we talked about. They're all smart contract based, or the best ones are the ones that work the best. Algorithmic stable coins, okay, they're a bit more experimental, but I think they're still exciting as a potential way of doing monetary systems, even though we've seen many failures. It's still something we couldn't do before. And then you also have DAOs, right? Decentralized autonomous organizations. And I keep banging on about the Constitution DAO, but I think it's so fascinating that crowdfunding, the ability to crowdfund on such a scale, and without knowing the people you're crowdfunding with, right? It's crazy that they nearly managed to buy the Constitution. And that was just a simple crowdfunding thing, right? That's just pooling resources. That's not a very complex smart contract. You're also seeing people encode like rules of organizations into smart contracts. And I don't see many companies being ruled purely by a DAO in the future. I think, again, like with normal contracts, you're going to have the old organizational structures in place as well. But they can make membership more efficient. They can make it easier to come and go or buy shares and leave from a company. So I think that's very interesting as well.
You just compressed an hour of our DeFi episode into about 5 minutes, or maybe 2 minutes, actually a bit less than that. But the amount of words you threw at people like DAOs, automatic money makers, DEXs, oracles, boom, no need to listen to that DeFi
That's
episode.
The highlights version.
Is the highlights version. Nice. I think a slightly more exciting one that could be applied to as well is the entertainment industry. Obviously, NFTs. I think the NFT craze is still going. I don't know. I'm not really sure anymore. It's hard to keep up with. But the idea of like the entertainment industry or individual content creators, artists, for example, being able to create a digital token or digital art and then create an NFT for it. And in that NFT, they can start to imbue smart contract rights around intellectual property, where it came from, royalty payments, for example. If I create an NFT that gets resold 10 times and I'm the original creator, I can actually embed in that NFT the actual functionality to say, okay, every time this is sold, I want 5% of the profit that's made from it. Things like that. And when we start to talk about the idea of, okay, IP, who actually owns this, who is the original creator, who's the authenticity. Well, this is a really hot topic right now around AI and all the things that are generated from AI. And we can start to think about, smart contracts managing the creations of AI and all this kind of stuff. And it's always fair compensation. There's not necessarily any delays or errors in that. It's very defined and black and white in a lot of ways, which has downsides and upsides.
Yeah, I agree. I think the kind of the media entertainment industry and the NFTs use case, right? Using NFTs in much more interesting ways and for royalties is definitely going to be part of the future. I think we're already seeing people exploring it, but it's so easy to encode simple rules that are very powerful for royalty payments in smart contracts, right? Every time the NFT gets transferred, then you add that person to the list of royalties and maybe reduce it by half or something like that. I've even seen Jack Butcher and the checks project, right? This is really interesting. It's kind of algorithmically generating new NFTs based on what previous NFTs were. And this is all smart contract based, right? It's using the smart contracts as part of the algorithm generating the NFTs, which is super exciting. Yeah, I think that's going to be part of the shift into utility tokenization in the future, right? Not just dumb JPEG NFTs, but things that can convey much more value, much more meaning in the future.
And that's a nice inroad to, I guess, the final part is, what does the future of smart contracts look like? I think you've touched on it there with that project you just mentioned. I think one of the big things for me, we talk about IoT a lot, and for good reason. I think the idea of smart cities and IoT driven smart cities, where going to have like 30 billion active IoT devices by 2025. How are we going to manage the interactions? And as these IoT devices start to have more intelligence, more agency, they start to have to interact with other IoT devices. Like, one of the good examples is the idea of a self-driving car refilling itself at a petrol station. Well, how is that interaction going to be managed? You're going to have some exchange of value. You're going to have some terms. You might even have to have some signature to say something actually happened and there's some authenticity around this. Well, that is a contract. And obviously, when we get to that space, we're going to start to need smart contracts to actually manage it, ensure transparency, ensure efficiency, because there's no way in hell that a lawyer is going to be able to keep up with that number of IoT devices. So I think that's an extremely exciting realm, the idea of IoT devices using smart contracts to interact in the wider world and interact in an open public world, quite importantly.
Oh yeah, I definitely think that's going to be huge. And we've been talking about smart cities for quite a while, but there are some huge projects happening around the world to make this a reality now. And I think smart contracts are very much seen as the tool to do that. Another thing I think is obviously a trend at the minute is everything AI and the convergence of AI and blockchain, or AI and smart contracts, as we've also touched on. And I think what will be really interesting is when you start having AI used to inject new types of insights and new types of data into these smart contracts, via oracles and things like that. So that smart contracts can start doing things that are, dare I say it, probabilistic. Okay. So we like to think of everything is very deterministic in the blockchain world. Everything is, this process goes to this. It's very well defined, but actually we can start injecting some new use cases into the Web3 world by using everything we're getting from the AI revolution right now. So I don't know what it's going to be exactly, right? It might be how contract decisions are made, or how you modify a contract, how you update it over time. Maybe it's randomly distributing rewards for a given piece of media or something like that. I don't know. Or trying to predict how often a smart contract is going to be needed to be used, and doing some clever things with, when you submit your transactions, that kind of stuff could be interesting as well. But yeah, I think broadly how smart contracts leverage AI going forward is going to be a massive thing.
You heard it here first. AI is going to be big, I think, maybe. Unsure. Let's see. Yeah, I think we're coming to the end of the show. That's a lot. Like, smart contracts is an extremely exciting topic, and there's so many more avenues we could go into, and we probably will expand on this in the future. I think overall, I'm feeling quite hopeful about this space. I think one of the things that we've kind of reiterated throughout the show is, yeah, there's a lot of efficiency improvements, but the world isn't binary, and we have to make that clear. There's always going to be a gray area between contracts, and we need to ensure that we don't try and program the entire world, because it might not be possible.
Yeah, I completely concur with your sentiment. The only thing I would add is how foolish I feel that we've taken well over half a year to get to the topic of smart contracts on a Web3 podcast, when that's one of the only things that people will actually have heard of before. So yeah, I'm glad we've done it now, at least.
It's daunting, right? Because contracts are so convoluted. There's so many elements to explain why smart contracts are valuable. But I hope we did it justice, and we almost certainly will have kind of more episodes on this to expand on the topic, because it is an interesting one and quite a technically complicated one as well.
Yeah, I think what we've done here is an example of podcrastination.
Oh God!
And on that bombshell, we'll say thank you to those listening wherever you may be, and join us next time to untangle a little more of Web3.
Thanks for tuning in to another episode of Untangling Web3, produced by Emma Camilleri.
Don't forget to send us your thoughts, questions, and comments on social media, and be sure to follow us on your favourite podcast provider to catch the next episode. See you next time to untangle a little bit more of Web3.
The views we express here are our own and do not reflect the views of our employers.